Hi again. Welcome to the video introducing many of the basic terms and concepts needed to be able to read a network diagram or a graph. Networks are an integral part of so many things we do, explicitly or implicitly. The terms and concepts we get here will enable us to establish a sound basis for our understanding of networks so we can then develop ways to analyse those networks. A network is a system of interconnected entities. In our worlds, we are frequently, either deliberately or unconsciously, involved in networks. Our networks may relate to our time on social media, our transport as we move from one place to another, in building and construction, particularly of our computer networks and our electricity networks to various parts, say, of our school, the ways a chemical molecule is structured, how we study for a major school or a public exam, and our problem solving and decision making. In all of these contexts, we view a network as being a group or a system of interconnected objects or stages represented by a diagram or a graph and incorporating lines and points. Let's take an example. I want to go for a walk from my home to a nearby park. Now, in the area, we have a shop and we also have a school and a bridge nearby. Now, each of these circles represents a stage I would pass along the way from home to the park. And we will refer to these circles as vertices or as nodes. They are the main points or the milestones on our walk. Now, one way I could go from home to the park is past the shop because I know that I can buy a nice ice cream there. The other way I could go to the park is past the school and over a very nice bridge with lots of running water under it. Now, I can't do both of those things, I can only do one. And so the blue lines indicate to us the way in which we could walk. And those blue lines are called edges. And the edges connect the vertices. Usually we use lines to represent the edges, but sometimes we can also use arcs, depending on how we've set up our diagram. In the network we have here, we have 5 vertices, which are the ones in circles, and we have 5 edges, which are the blue lines. Now, if 2 vertices have an edge between them, we say that those vertices are adjacent to each other. It is possible to have multiple edges attached to the same vertex. In our diagram, each vertex is associated with 2 edges. In C, for example, for the shop, we have one edge coming from home and we have another edge going to the park. If we want to describe how complex a vertex is, we just simply determine the degree of that vertex, which is the number of edges coming into it. So we have another diagram in which we have A, B, C, D, E as being the vertices and the lines joining them being the edges. And if we have a look at vertex A, then there is an edge coming from B and an edge coming from E, so the degree of vertex A must be 2. Similarly, C and E are also of degree 2. Whereas if we look at B and D, then we've got degrees of 3 because there are 3 edges coming into each of those. If we have a vertex with 2, 4, 6 and so forth edges, we say that's of even degree because they're of even numbers. A vertex with 1, 3, 5 and so forth edges is said to be of odd degree because we have an odd number of edges coming into them. Now, every edge has 2 vertices attached to it, one on either end. So therefore the sum of the degrees of all the vertices in a network must equal 2 times the number of edges in that network. So the number of degrees in any network is always going to be an even number. So if we add up all of the degrees in our diagram, we have 3 vertices with a degree of 2 and 2 vertices with a degree of 3, so that gives us a sum of all the degrees, which is 12, and the number of edges we have in the diagram is 6. So, proves our point. The sum of all the degrees of all the vertices, which is 12, is equal to 2 times 6. It works. When we draw our network, it can be drawn in many different ways, as long as the information is the same. It's going to be the same communication, but some networks are easier to read than others. Now I've got 2 pictures here. They're both exactly the same network, but they look different. So for example, on the left-hand one, W vertex to X vertex, the edge is 4, and in the other diagram, along the top line, from W to X vertex, the edge is 4, and so on and so forth. But really, the right-hand one looks better, doesn't it? It's nicer to visually have non-crossing edges. We've got 2 crossing edges in the first diagram. It doesn't look so nice. So if you want to have the nice effect of non-crossing edges, to make it easier to analyse, then you rearrange the vertices. Now, to give yourself some experience in rearranging the vertices, and to have a little bit of fun as well, have a few games of planarity. And just to check the website of details and the link for that. It's good fun, and it gives you an understanding of how to move things around. Now, some networks incorporate directed edges. These are edges with small arrowheads to indicate the path only goes in one direction along that edge. Now, to demonstrate this, let's play scissors, paper, rock for a minute. We know that scissors beats paper, so therefore we can have a directional arrow saying scissors beats paper. Paper beats rock, so therefore we've got the arrow going down to rock, but rock beats scissors, so we've got the arrow going up there. So we have our 3 edges, they've got arrows on each of them, and they tell us the direction in which we can move. So the edges with the arrowheads indicate direction, and we describe the graph we've now got as representing a directed network. Another good example of a network with directed edges is the World Wide Web. Pages on the web are vertices, or the nodes. The edges are all directed because a reference from one site leads in one direction to another site or another page. Take another example, little diagram, and we notice that there are arrows on each of the edges in our diagram. Now, it is possible to travel directly from A to C along that horizontal arrow, or we could travel to C from A via B. But it's not possible to travel from C to A directly. If we want to do C to A, then we have to go from C to D, from D to E, and from E to A. The edges in a network diagram often have numbers written about midway along them. These numbers can refer to various features, including how long it will take to move between the 2 vertices, how far apart the vertices are in terms of centimetres or kilometres or whatever, and how much the activity will cost to move from one to another. The numbers that we use along the edges are commonly referred to as weights, and so the edge on which the weights are written are called weighted edges. So we have a look at our modified diagram because now I've put blue numbers in there to indicate these weights. So each of those blue numbers is a weight, and the weight of the network is going to be the sum of all of its weights. So we just add the numbers, 5 plus 6 plus 7 plus 6 plus 4 plus 9 gives us 37. So the weight of this network is 37. That'll come very important in a future video. So to summarise what we've done here in terms of our concepts and our terms. Vertices, or nodes as they're sometimes called, are the activities or stages in a network diagram. The edges are the lines connecting the vertices. If we want the degree of a vertex, that's simply the number of edges coming into it. The directed edges are edges with an arrow on them. Weighted edges are edges with a number indicating time, cost, etc. We know that several network diagrams can be drawn from the one set of data, and we also know that the total degree of a network is always an even number and always equals twice the number of edges. In this video, we have established the basic concepts for understanding networks and the diagrams which represent them. The summary is also available on the website. In the next video, we extend that understanding by examining the various ways we can move through a network. Consolidate what you have learnt here by doing the test yourself questions on the website drjaysmaths.com. Hit the like button and subscribe if you haven't already, then you get notifications about new videos. Good luck. See you on another network video.